All right, this is our second one about exponents and scientific notation. After this, we will go on to polynomials. So we're just going to get into more detail about the power rule, specifically how to distribute exponents through the parentheses. So the power rule, or the power of a product rule, or the power of a quotient rule for exponents will just show us how to distribute an exponent to multiple terms. Okay, so the power rule is if you have one base raised to a power within the parentheses and then raised to a second power outside the parentheses, you want to multiply the exponents but keep the base. So remember, we've learned that a to the power of m times a to the power of n is just a to the power of m plus n. However, that is different from a to the power of m being then raised to the power of n. Then you are going to take m and multiply it by n. That is the difference, okay? If you're just multiplying two of the same base with different exponents, you're adding the exponents. But if you're taking that base and exponent and raising it to another exponent, you're going to multiply the exponents. Good. Now, power of a product shows that anything directly outside of parentheses gets applied to everything inside the parentheses. So ab to the power of n becomes a to the power of n times b to the power of n because they were already being multiplied inside the parentheses, and we're going to distribute the n, which was directly outside the parentheses, into those parentheses. Good. Power of a quotient, same thing. Anything outside the parentheses, and we're talking about directly outside the parentheses, gets applied to everything within the parentheses. A divided by b to the power of n becomes a to the power of n over b to the power of n. Example 1, use the power rule to simplify each expression and use positive exponents only. That will be true for everything we do in 5.1 and 5.2. So this is y to the power of 2 to the power raised to the power of 8. Remember, the power rule is a to the power of m raised to n is a to the power of m times n. Good. So we're going to take that 8 and we're going to multiply it by 2. So that becomes y to the power of 2 times 8, which is y to the power of 16. Good. B is 3 to the power of 3 raised to the power of 2. So that becomes 3 to the power of 3 times 2. So we're multiplying 3 times 2. So it's 3 to the power of 6. Good. You can also solve that. 3 to the power of 6 is 729. And if you would like to put it into your calculator just as they have it, they had it as 3 to the power of 3 to the power of 2. Get the same answer. 6 to the power of 2 to the power of negative 1. Remember, you're multiplying, becomes 6 to the power of 2 times negative 1, which is 6 to the power of negative 2. Remember, it says write each answer with only positive exponents. So 6 to the power of negative 2 becomes 1 over 6 to the power of positive 2 because you have a negative exponent. So the term adjacent to that negative exponent is going to get moved across the fraction bar. If it's down here with a negative, move it to the top. If it's up here or alone, move it to the bottom of the fraction. And the negative exponent will become a positive exponent. Here we have x to the power of negative 5 raised to the power of negative 7. So we're going to multiply negative 5 by negative 7. Think about this. You're going to have two negatives. So what happens when you multiply two negatives? They become a positive. So 5 times 7 is 35. So our answer is just x to the power of positive 35. Good. Okay. Same here. Remember, we're going to distribute this 3 to everything inside the parentheses. So I can rewrite this as 3 to the power of 3 times x to the power of 4 times 3, right? Because that x to the fourth to the third power means I need to multiply the 4 times the 3. The 3 is now going to be raised to a 3. 3 to the third power, you can put in your calculator. It's 27 because 3 times 3 is 9. 9 times 3 is 27. So we have 27x to the 12th because 4 times 3 is 12. Everything was positive in that one. Here, this is the quotient rule. So that was the product rule because it was the product of 3 times x to the 4th. Now we have the quotient 4 divided by 5. So that's now 4 squared over 5 squared. 4 squared is 16, 5 squared is 25. I think we just leave it like that. I don't think that there's any way to simplify 16 over 25. You can't divide them both by 5. You can't divide them both by 2. All right, now we are going to use the product rule and the quotient rule at the same time. So we have 2, I'm just going to go one item at a time, 2 to the power of 4. I'm going to apply the 4 to each item at a time. X to the power of 4 times 4, 3 to the power of 4, y to the power of 5 times 4. Good. 2 to the 4th is 16. I'll probably just go down here. So 2 to the 4th becomes 16. X to the 4 times 4 is x to the 16th. 3 to the 4th, you can put that in your calculator. 81, because 3 to the 3rd was 27. 27 times 3 is 81. So 3 to the 4th is 81. And then we have y to the 5 times 4, so y to the 20th. Everything is positive. Can anything be reduced? Do 16 and 81 have any common factors? I don't think so. So I would just leave it like that. Everything's positive, and we've simplified it as much as we can. Now we have -5, x to the 3rd, y squared, z to the 4th, all raised to the power of 2. So just like we distributed that 4 to all of these parts, we're going to distribute that 2 to each one of these terms. So -5 is inside the parentheses, so it's -5 squared. Good. The negative's inside the parentheses, so it becomes -5 squared times x to the 3rd times 2, y to the power of 2 times 2, z to the power of 4 times 2. So I distributed that 2 to everything. -5 squared, if I keep my parentheses around the negative sign, becomes a positive 25. 3 times 2 is 6, so that's x to the 6th. 2 times 2 is 4, so that's y to the 4th. And 4 times 2 is 8, so that's z to the 8th. That is as simple as you can make it. Good. Now, let's look at all the exponent rules we have learned so far. So this is everything. The product rule is the same base with exponents. You add those being multiplied together, you're going to add those exponents. A base to an exponent raised to another exponent, you're going to multiply those exponents. The power of a product means you're going to distribute that exponent to everything inside the parentheses. Same with the quotient, you're going to distribute the n to both parts of the fraction. And the quotient rule is when we multiply them, we're adding the exponents. When we divide them, we're subtracting the exponents. Anything raised to 0 is automatically 1. And then if I want to get rid of a negative exponent, I move it across the fraction bar, just like 1 over a to the negative n is the same as a to the positive n, right? So if the negative's down here, you can make it positive by moving it up here. If it's negative up here, you can make it positive by moving it down here. Now we're still simplifying, but now I have a -2. So I'm going to take that -2 and apply it to everything. So I have 2 to the power of -2, x to the power of 0 times -2, y to the power of -3 times -2. Good? Because what I'm doing is I'm applying this rule where if you have exponents inside and outside of the parentheses, you're going to multiply those together. Good. So 2 to the power of -2. I'll just call it 2 to the -2. X to the power of 0 times -2 is just x to the 0 power, right? Because 0 times -2 is 0. And then y to the power of -3 times -2 is a +6. Is that okay? All right, so now I have a negative exponent. If I have a negative exponent, I want to take that exponent in that base, move it across the fraction bar. Good. Think about these two are positive or 0. These two are not negative, so we can keep them on the top. So I have 2 squared on the bottom of my fraction, x to the 0. What did we say happens? Anything raised to the 0 power is 1, so that just becomes 1 times y to the 6th. 1 times y to the 6th is exactly the same as y to the 6th, so I'm just going to leave it like this. And it's done. Oh no, sorry, it's not done. Y to the 6th is done over 2 squared, which is just 4. So I would change that to y to the 6th over 4. It was almost done. Here we have x to the -5th over x to the -2nd divided by, or sorry, raised to the power of x to the -3. So you're welcome to do that inside the parentheses first, because those are the same base, right? So you can use, it's possible to use the product of a quotient first. It might be easier to use the quotient rule first, okay? So I can immediately say that that is x to the power of -5 minus -2 to the power of -3 because of the quotient rule. A to the power of m divided by a to the power of n becomes a to the power of m minus n. So that's now x to the power of -5 plus 2 raised to -3. Good. X to the power of -5 plus 2 is x to the power of -3, right? Raised to -3, which is x to the power of -3 times -3, which is x to the power of 9. Good. Or, like I said, there's another way to do it. You can say x to the power of -5 times -3 over x to the power of -2 times -3. That will give you the same answer. That's x to the power of -5 times -3 over x to the power of -2 times -3, which is x to the power of 15 over x to the power of 6. Good. And now we're going to apply the quotient rule, which is subtracting. So x to the power of 15 minus 6 is x to the power of 9. So either way, you get x to the power of 9. You can do the subtraction first. Here we did the subtraction last. Here I did the subtraction first. Three-fifths to the power of -2. 3. Couple steps ahead. 3 to the power of -2 over 5 to the power of -2. I want them to be positive. They are both negative. So what I'm going to do is I'm going to take the 5, move it up here, take the 3, move it down here. If I do that, they'll both those exponents will become positive. So it will now be 5 squared on top over 3 squared on the bottom. 5 squared is 25. 3 squared is 9. So it's 25 over 9. All right. Here we don't have any parentheses, so we're not distributing anything. We're just simplifying, okay? So 6 to the power of -2, I know already I need to move that. So that's going to get moved so that the -2 becomes a +2. I also know that x to the -4, I'm going to need to move that x to the -4 so that it's a positive. And I know that this y to the -6, I want to be positive, so it's going to go up here. So all my first step is moving things across the fraction bar. 6 squared is now on the bottom, but the squared is a positive. This x squared did not need to move. Sorry, I just went from here to here. That doesn't make much sense. Let's keep going. 6 to the negative 2 becomes 6 squared. X to the negative 4th becomes x to the positive 4th down at the bottom. Y to the 10th stays on the top. So of these three terms, these two move to the bottom, this will move to the top. This one stays on the bottom. It's just x squared. It didn't need to move. Y to the negative 6, we needed to move up here, so it becomes y to the positive 6. Good. So I moved the 6 down here, I moved this x down here, I moved this y up here. Now I can just simplify. Y to the 10th times y to the 6th is y to the 10 plus 6 power. 6 squared is 36, because 6 times 6 is 36. X squared times x fourth is to the 4th is just x to the power of 2 plus 4. Remember, we're just adding when it's adding the exponents when we're multiplying the bases. So it's y to the power of 16 over 36 x to the 6th. Good. And that's as simple as I can make it because each of those terms is alone. So there's nothing I can cancel out across the fraction bar. Here, I'm going to be simplifying probably the b's, and I'm going to be distributing this -2. Okay, you can simplify the b first, or you can distribute the -2 first. It does not matter. Okay, so 4, I'm going to start with just distributing the -2. 4 to the power of -2 times a to the power of 3 times -2 times b to the power of 2 times -2 over b to the power of -6 times -2, c to the power of -2. Good. All right. Let's see what else. What I'm gonna rewrite it all. So 4 to the power of -2 times a, 3 times -2 is a -6, times b, 2 times -2 is a -4. So all the terms on top are negative exponents. B to the power of positive 12, that's nice, times c to the power of -2. So I think I'm going to have to move a lot of my terms. I'm going to move the 4 down. I'm going to move this a down because they're negative, and I'm going to move the b down. So everything on top gets moved to the bottom because they are negative. We want them positive. And on the bottom, I have to move that c up. Okay, so that becomes, what is the only thing that's staying? B12 is staying. 4 squared is moving. A to the 6th is moving, and b to the 4th is moving, and then the c squared is moving. Good. All right, so that becomes that remains c squared on top. 4 squared is 16. I always like to have the number out in front. A to the 6th times b 12 plus 4, because we're multiplying b to the 12th times b to the 4th, c squared over 16 a to the 6th b to the 16th. Again, we're just going to distribute a -2 to all of these and make it super clear. All right, 3 to the -2 is being raised to the -2nd power. It's going to be multiplied by a to the power of 3 multiplied to the -2nd power, multiplied by b raised to the -2nd power, over 3 to the -4th raised to the -2nd power, a to the 7th raised to the -2nd power, b to the -3rd raised to the -2nd power. Good. So that's just a visual of what we've been doing each of these times. I've kind of been skipping straight to the multiplication, but that's what it looks like when you truly distribute the one exponent to everything inside parentheses. So 3 -2 times -2 is what that becomes, right? Times 7 times -2 times b to the power of -3 times -2. Good. So Let's simplify this. This is 3 to the power of positive 4. This is a to the power of negative 6. And this is b to the power of negative 2. This is 3 to the power of 8. A to the power of negative 14. And b to the power of positive 6. Is that okay? All right, so let's start moving things. What do I need to move? On the top, I need to move the A and the B. On the bottom, I just need to move the A. If I rewrote that, I would have 3 to the 4th times, that's all I keep up there. Those two are gone. On the bottom, 3 to the 8th, a to the negative 14th becomes a positive 14. And then b to the 6th stays. And then we need to include the a to the, oops, sorry, it's down here. So this is moving. A to the 6th is moving and b squared is moving. Good. All right. So what I can do is I can combine those b's. So that's 3 to the 4th, a to the 14th over 3 to the 8th, b to the, sorry, I put that out of order. Let's put a first. A to the 6th, b to the 8th, because 6 plus 2 is 8. Good. Okay. Instead of saying 3 to the 4th is 81, we can just say we're keeping the same base and we're going to say 4 minus 8 for 3. Okay. Times a to the power of 14 minus 6 times over b to the 8th, because the only b is below the fraction bar. Good. So what I used here was I used the quotient rule, where you take m and you subtract n if the bases are the same. So that becomes 3 to the power of negative 4 times a to the power of 8 over b to the power of 8. One more change. This is a negative, so we're going to move it down. So that becomes a to the 8th over 3 to the 4th, b to the 8th. And then you can just simplify by saying what 3 to the 4th is. We decided it was 81. It's 81. So it's a to the 8th over b to the 8th times 81. Sorry, I said that out of order. All right. Example 6. Keep simplifying. So we have x to the negative b. And then we're going to take this 2 outside the exponent, or outside the parentheses, and move it in, and apply it to both the 2 and the x to the power of b. Is that what that is? It's a bunch of letters. X to the negative b times 2 squared times x to the power of b times 2. Any questions? I mean, about how I got that? I guess you can't ask because it's a video. Now, I am going to think about a fraction because this is a negative b. So I'm going to put x to a positive b on the bottom. I'm just going to move that immediately. 2 squared is 4. And then x to the power of b times 2 is the same as x to the power of 2b. Good. All right. This is 1b on the bottom. And remember, you can subtract exponents. So this is actually 4 times x to the power of 2b minus b. You can subtract 2b minus b. Even if you don't know what b is, it just leaves you with 1b. So that becomes 4x to the power of b. There's another way to do it. So back when you had x to the negative b times 2 squared times x to the 2b right here, right? You can combine these. So you can say this is 2 squared x negative b x 2b. Okay. When you have the same base and you're multiplying them, you can add the exponents, right? So we know 2 times 2, 2 squared is 4. And then this is x minus b plus 2b. So 4x, 2b minus b is just b. So 2 different ways to get that answer. And then here's another b. Y to the power of 3a raised to the second power over y to the power of a minus 6. Good. All right. That just becomes y to the power of 3a times 2 over y to the power of a minus 6. Y to the power of 3 times 2 is 6a over y a minus 6. Good. That's all you can do there. Make sure you know the 5 exponent rules, okay? The 5 exponent rules are x to the power of m times x to the power of n equals x m plus n. X over to the power of m over x to the power of n is x to the power of m minus n. X to the power of m raised to the power of n is x to the power of m times n, and that x to 0 is always 1, and that x to the power of negative m is the same as 1 over x to the positive m. Good. All right, so make sure you know these. These are ready for use whenever you need it. Let's talk about scientific notation again. All right, so you've had some practice in 5.1 with scientific notation. Honestly, if you haven't done the scientific notation homework for 5.1, don't watch this because this is just adding complexity to it. So if you haven't practiced it and you're not comfortable with scientific notation yet, go back to 5.1. We don't want this to be a waste of time. Basically, when you have to multiply terms that are already in scientific notation, you're going to multiply the decimal numbers and then add the exponents of the power of 10. So keep the 10. So keep the base of your exponents. And just like the rule that when you are multiplying exponents, you just add them. Scientific notation is exponents, but your base is always 10. Okay? So you keep the base of 10 and you add the exponents because you're multiplying scientific notation, okay? Then make sure it's in its simplest form. So here is an example. 2 times 10 to the 4th times 3 times 10 to the power of 3 becomes, multiply the decimal numbers. There's no decimal, but they just mean multiply the coefficients, okay? 2 times 3 is 6, right? All right, keep the base 10. 10 to the 4th times 10 to the 3rd is, keep the base of 10. 4 times 3 is 12. So my answer is 6 times 10 to the 12th. Oh, sorry, we add them. 7. Do not multiply those. I've been doing a little too much of distributing that. That would be very, very wrong. Good? All right, add your exponents. Make sure you simplify because you can, remember with scientific notation, you can only have 1 digit to the left of the decimal. All right, that might come up. Let's make up another one. 2.1 times 10 to the negative 3rd times 2.798 times 10 to the negative 9th. Okay, so you're still going to multiply the decimal numbers, multiply the coefficients. 2 Don't have a 3 in there already. 2.1 times 2.798 is 5.8758. 5.8758. Good. Sorry, I should explain what I did. That was 2.1 times 2.798 equals that number. Take your bases of 10. 10 to the negative 3 times 10 to the negative 9th is 10 to the negative 3 plus negative 9, right? So that becomes 10 to the negative 12th. Put those together. So we got 5.8758 times 10 to the negative 12th. Good. All right, let's do another one. We'll do 4.2 times, sorry, I shouldn't be writing a different multiplication symbol, times 10 to the 4th times 2.9 times 10 to the 9th. Good. So we're going to say 4.2 times 2.9 is 12.18. 10 to the 4th times 10 to the 9th. We're just keeping the base. We're using the rule of exponents. You keep the base and you add 4 plus 9. 10 to the 13th. Good. So then it becomes 12.18 times 10 to the 13th. But remember, we need only one digit in front of the decimal. That's the whole point of scientific notation. So in order to keep this, instead of as a 12, I need it to be a 1. Okay? Think about that. Think about which direction you go and what that means for your exponent of 10. Okay? 12.18 is the same as 1.218. I moved the decimal point left, right? If I move it left, positive. If I move the decimal point left, my exponent is positive. Okay. 12.18 becomes 1.28 times 10 to the power of 1. A positive exponent because I moved the decimal left. And let's check that. 1.218 times 10 to the power of 1 or times 10 is 12.18. So when you move the decimal point left, your exponent is positive, the number of places you moved. I moved it 1. It's just like multiplying it by 10, right? Left positive. So that is actually 1.218 times 10 in scientific notation. Okay, let's do one more. Let's run out of space. 8 times 10 to the 3rd times 9 times 10 squared. Good. First, we're going to multiply the decimal numbers. 8 times 9 is 72. And then 10 to the 3rd times 10 squared is 10 to the power of 3 plus 2, which is 10 to the 5th. So I have 72 times 10 to the 5th. Ooh, sorry. 10 to the 1. I did not finish it down here. I just looked down here. Times 10 to the 1 times, and then you got to bring this back. 10 to the 13th. Remember, when you're adding exponents, when you're multiplying with the same base, you keep the base, add the exponents. So that is actually 1.218 times 10 to the 14th instead of the 13th, because we moved one decimal place. I apologize. All right, so this one is similar position, 72 times 10 to the 5th. We're done, except that the decimal point is here. I need the decimal point here. I move the decimal point left. Positive. So that's going to be a positive 1. So 72 becomes 7.12 times 10 to the 1st. 7.2 times 10 is 72. So I moved it left. It's going to be a positive exponent. So now that's 7.2 times 10 to the power of 1 times that original 10 to the 5th, just like we did here. We brought that back after we changed this to scientific notation. So 7.2 stays the same. 10 to the 1st times 10 to the 5th is just 10 to the 6th. Final answer. Good. All right, so just like multiplying in scientific notation meant multiply these terms, add the exponents. Dividing in scientific notation, we're going to divide the decimal numbers, subtract the exponents, just like the exponent rule says. All right, so let's start. For my first example, we're going to do 9 times 10 to the 8th over 3 times 10 to the 5th. Good. So just look at your decimal. Just look at your exponent. You're going to divide the decimal, subtract the exponent. Okay, you can keep them separate. 9 divided by 3 becomes 3, right? Times 10 to the 8th minus the 5th, right? Because 10 to the 8th over 10 to the 5th is simplified to 10 to the power of 8 minus 5. So I take the exponent of my numerator, subtract the exponent of my denominator. 8 minus 5 is 10 to the 3rd. So that's 3 times 10 to the 3rd. Good. Okay, let's do another one. 6 times 10 to the negative 2 to the power of negative 2 over 5 times 10 to the power of negative 6. Good. All right, 6 divided by 5. Don't worry about keeping it as a fraction, because in scientific notation, you're never going to use fractions. You're just going to call 6 divided by 5 1.2. Okay. And then 10 to the negative 2 over 10 to the negative 6 becomes 10 to the power of negative 2 minus negative 6, right? So 10 negative 2 minus negative 6 is the same as negative 2 plus 6. Ten to the 4th. Good. So that's 1.2 times 10 to the 4th as our final answer. Let's do 5.3 times 10 to the negative 3rd over 7.65 times 10 to the negative 5th. Good. 5.3 divided by 7.65 is point. So 5.3 divided by 7.65 is 0.69281. 10 to the negative 3 over 10 to the negative 5 is 10 to the power of -3 minus -5. Good. -3 minus -5 is the same as -3 plus 5. -3 plus 5 is 2. So if we bring those together, we have 0.69. I guess 0.69281 times 10 squared. Good. All right, what is wrong with this? I don't have a number in front of my decimal, right? It's 0. So what do I need to do? I need to move this decimal place 1. Do I need to move it left or right? That was a right move. Remember, R-I-G-H-T. Right means negative. So 0.69281 is the same as 6.9281 times 10 to the first, right? But it's negative because I moved to the right. 6.9281 times 10 to the power of -1 is 0.69281. You can check it in your calculator. Good. Don't forget, we're already multiplying it by 10 to the power of 2 from over here. So here we're just changing it back into scientific notation. And then you need to include the end of your original scientific notation. So times 10 to the power of 2. And we have 6.9281 times 10, to the power of 2 minus 1, right? 6.9281 times 10 to the power of 1, or times 10. All right, one more. A, B, C, D. 7.8 times 10 to the 4th over 8 times 10, just 10. Good. 7.8 divided by 8. Now, 0.975. 10 to the 4th divided by 10 is 10 to the power of 4 minus 1, which is 10 to the 3rd. So I have 0.975 times 10 to the 3rd. I need to move it 1 decimal place to the right. Right is negative. So I have 9.75 times 10 to the -1 times the original 10 to the 3rd. So that becomes 9.75 times 10, -1 plus 3, 9.75 times 10 squared. All right, that is multiplying and dividing in scientific notation. Feel free to send me an email if you have any questions.